Hello. I'm starting the SQL presentation, slash workshop right now. So today is just basically theory and also a bit of how the language works. Then on the second one, we're basically going on March 12th. We're going to delve deeper into how to do queries in SQL. Like first, here's going to just start off like fairly basic. So here's the content. We'll start from motivation and like basically various different implementations of SQL, like SQLite is what we're using right now, which is fairly good for teaching. And then we're going relational data, the theory behind it, relational databases, the ER model, normalization, then how to query in SQL. So how to follow along, basically go to that website, and that basically tells you how to follow along. Here I'll show, should bring you to this website right here. Okay, then download the zip file. That's on the red corner right here. See where it's circled? Download the zip file from there, and then unzip the download file in whatever directory you want. So has everybody done that? Everybody's done it? So keep going? Okay. Then basically start open up an SQLite browser. Like open up our SQLDB, that's our basically test data. Then click on Execute SQL tab, open up the Intro SQLite presentation one file, and basically go then follow along on with the content on the website. To show you how to do that, basically open up the database right here. It's already open for me, but so where I have this is currently in Intro SQL, and see Stats Club DB. Open up that file, and should bring it here. In Execute SQL, open up here. Same thing. Go where you download it. Download that file to, and Intro SQL. And from here, you can basically follow along with the examples. When you see an example going on, you can highlight whatever command you want and press play, and it executes that query and shows up right here. So has everybody gone that far? Has everybody not gone that far yet?
What's the name of the file?
The database? There's two. Yes, that's fine. Yep. Yeah. Now, when you So anybody else need to get that far? So everybody gone this far? Run a bit late, but so everybody gone this far? Good. Probably go browse through some of the features. One of the nice things about SQLite browser, you could actually see the structure of your the data of your data set, of database. So it tells you like what kind of what kind of values are in each column, what kind of, and also kind of specifies how things are going. Like for instance, that create table there, that actually tells you how you can create that table in with just the command. That actually tells you the command right there. You can also explore the data, enter in various tables. So you could basically, when browse data, select the table you want, and you can see the data right there. You could also execute SQL statements right in the browser. So just highlight what you want and click on press play there, the little symbol right here. And it should execute the statement and see the results down below. Yeah, it could also easily construct tables from files, like import files. Would even export what you have right now into an SQL file. If the table's already created, you could also import data right into your table with a CSV file, where you basically just import your CSV file, table name, if the header's already in the file, and separator, and I'll just do it up for you. So why learn a database language? Data is rarely ever tidy, and as they are in many stat courses, so you kind of want to know how to basically process the data, and this SQL kind of helps you there. And also, most of their data is not on your computer; it's usually out there somewhere, and usually on some SQL server. So why learn SQL? Is one of the more popular languages for data analysis. According to O'Reilly and Data Science Survey. It's also one of the most in-demand skills for 2014, and could help you retrieve your data, even slice up the data, manipulate it as much as you want. So it helps you figure out what kind of information you want from it. So SQL is a programming language allowing multiple users to access the same data at the same time. It's quite. I won't go into how it does this, but it's interesting. It also uses relational database, a language, which basically relational algebra, was what it uses, is somewhat like regular algebra, but uses tables instead of numbers, if you can understand that. So it could do like the whole distributive properties and all that stuff with those kind of tables, and figures out what's the best way. It's quite ingenious paradigm. Also for SQL, data doesn't have to fit into memory, so you could do calculations over huge data sets and not have to worry of like having only 4 gigabytes of RAM. So why SQLite browser is easy to install. It's easy to share your files, your databases. Like for MySQL, there's no central place for the database. It's not a single file. it's a system, and also it's a good way to learn SQL. So various different implementations like MySQL. It's pretty good, a popular one for web development. PostgreSQL is pretty good for like making up your own functions. It has a lot of add-ons, a lot of extensions. It's even been reading up on extension has worked for machine learning. It has a machine learning paradigm in there, so you could actually do up all the calculations, not have to worry about too much for doing it by our SQLite browser. It's probably the most popular one. Like for instance, all your cell phones have it pre-installed. All these Macs have SQLite browser and SQLite already installed. Like every Mac has SQLite installed already. Web browsers have it. It's almost everywhere. Oracle is also another open source one for Oracle. Microsoft SQL, that's a pretty good one too. Remember seeing some functions for like even do linear regression on the server using servered files. And, DB2 is basically what Waterloo uses. So relational database. Relational database is organized tables containing records, rows, and attributes, columns. Each our tables is identified by a characteristic of called primary key, and foreign keys basically reference other tables, so they can actually describe kind of relationships between various tables. So the field is attribute, individual piece of data, so the column, and the row is basically a table of columns describing like an entry of usually an observation or something like that. So table is collection of rows. Usually we reference that to basically something stored on memory on your hard drive. Result set is basically a non-persistent one. It's basically the result of a query, which is basically what we're going to be focusing on. And a virtual view is basically a named query that makes it look very much like, to our end, very much like a table, but it's an executed query that basically results in a table, and we can actually work with that as well. Subquery is basically it's query that's inside of another query, so you can go deeper into it. It's kind of interesting, and because of this, you could do a lot of power, and also there's also because of this there's SQL queries that are like 100 lines long, so so get pretty extensive. Yep.
What's the formal definition for a query? What's a query?
Query is basically I want this table manipulated this way. Basically what we're working with right now. Select whatever from this table. It's
Is it the action or the down?
a query. It's basically a command that gives back a table. You can think of it that way. So primary key is basically what we use to identify, uniquely identify each row. A tuple of column and a foreign key is basically as a tuple of columns identify a relationship from one table to another table. So going to basically the bit of the ER model, that's an entity relationship model. It's basically another way of analyzing what's for relational database. When you actually basically understand the relationships, you basically understand quite a bit of how that organization is run. Like for instance, here's like I'm going to show you later on one for us, and that basically tells us kind of identifies like what a stats club does. So like for instance, every event can have a name, a type, like social or educational, location. Stats club members have like name, quest ID, email. So, and objects are basically related to each other through relationships. So basically stats club members attend events. And yeah, so here's basically many to many relationship right here, which basically many stat club members attend many events. So like basically there could be one-to-one relationships or one-to-many relationships. For one instance of one-to-one is basically every student has their own Quest ID account. And one-to-many is basically every course section has many students. And many-to-one is many students enrolled in a single course section. And yeah, and many is basically many instances of one object result in an indeterminate number of instances of another object. So normalization, this is basically how we organize relational databases so that it works good and clean and fun. So we basically, it's a process to relate to minimize redundancy and data is organized so that we could just basically add information in no problem. Deletions no problems. Everything is works out good. Data goes through three forms. We first normalized form. It's basically only atomic values and only single value for each column. So you can't have like multiple values for you can't have multiple names. For instance, for what we had earlier for stat club members, you can't have stat club members don't have multiple names. And yeah, and second normalized form, each attribute is dependent on the entry it's describing. So you can think of this as basically each row basically is a single observation. So like basically for each row is only determines one student. Like two rows can't determine the same student. Third normalized form is basically all non-primary keys are determined but are not determined by other non-primary keys. So everything's determined by that primary key. It's all dependent on that. So first of all, like for Stats Club, we could have like a data that's everything everywhere. We have details for events, like SQL. We have type, location, budget, like what Stat Club members does. So yeah, we have and lists of expenses. Like later on, we're gonna have Subway and MC Comfy. I'm hoping we have enough for everybody, but so something like this. If we were doing up a budget, might have something like this here. So first, need to tabulate the data. So we have basically event type information, member, attendance. The data is not in a form that's easily recognizable by computers here. So, like, how do you add new events? Like, how would that work? And what about members that attend multiple events? Like, you have duplication here quite often, and also members that attend no events. Like, some people don't attend events. So first, normalized form. Each attribute contains only atomic values. So, like, we bring what we had before into normalized form. For an event, there's inter-SQL education, like, and then basically information on the event, and then attendee's name, and we have expenses, so that we basically there's no redundancy here. So well, there's less redundancy here. So then,
Sorry.
yeah.
So you said that attribute contains only atomic values? What does that mean?
Basically, primitive data types like strings or numbers. You can't have multiple numbers in the same column. You can't have multiple. You can't have multiple like strings in the same column. It's just basically either a string, a number, or whatever.
Does that mean there's only one
One type for each.
associated to
Yeah,
each
one type
item?
associated for each column. Yeah, it's. There's also no SQL, which basically kind of lacks that objective, and it's a little more flexible, but also less consistent. So. What? Data type. What? One data type for each column. So, like these tables basically contain all the information, but not very easy for computers to deal with. Still, yeah, we still need to basically work on this a bit more. Like misspelling an event, and all of a sudden we have some weird event going on that nobody knows about. It's like, second line normalized form. Each attribute in tables dependent on the. So like basically each observation is unique. Each is tables organized so that so the rows are basically correspond to one observation. So you can almost think of each row as independent of any other kind of row. To bring in what we had in normalized form, we need to break the event table again. So that basically we need to basically just have information of what the critical aspects of an event is, like what's the name, what's the type, what the presenter is, organizer, list of members that attend each events. So, like for instance, right here, like for our event, we basically have like various different events, and like we have attendance for each event. And attendance is now in second normalized form, and we consider primary key as the tuple. It still has redundant information, but we're going to take that in a third normalized form. So all non-primary key attributes are not determined by any other non-primary keys. So if we bring it back, we basically break member down to events, and so we basically now have events, expenses, attendance for each event, and members. So that basically, so now we originally had like something at 4. Now we have we used to have like one thing that's really hard for computers to handle. Now we broke it up into 4 different parts, where basically we minimize as much as we can of any redundancy. Like, everybody understand that part? So far,
Sorry.
yeah.
Would you mind explaining what's the difference between primary, secondary, tertiary?
First normalized form, basically atomic values. Like each column is its own determined data type. Second normalized form, basically, I believe every row is a term for is every row is every row is relates to like one observation. Like for instance, Fred here went to Intro to SQL. That basically isn't there. And basically there's several members. So there's only one Fred here. There's only one Ryan. Okay. So go on to primary and foreign keys. This basically just to get bit of understanding what the methodology behind this is, so you don't have to worry too much. Just review it, and it's helpful for understanding how to grasp how to work within SQL. So primary foreign keys, like we can construct original tables by joining up other tables to each other using the primary and foreign keys. Foreign keys are basically a subset of what the referencing. So we can only construct an instance of foreign keys when we already have an instance of the reference of the primary key itself. Yeah. So, like for instance, what we had before, our primary keys, we had for the table of tenants, we had an event and a request ID for primary key, and also each event and each quest ID is also a foreign key. So event references the name of an event, and quest ID references a quest ID for a member, and for expenses basically references a single event, so that we basically can get all this information up and together. Yeah. So, little quiz here. Just basically try to normalize the following table here. So basically try to break it down into two tables to basically so that it's in third normalized form. So yeah, just spend like a couple minutes trying that to basically get an understanding of what normalized form is. Just try working on it. Not being graded, so doesn't carry. Yeah. So it's basically reorganizing, so each row, for that particular horizontal, each row corresponds to like one observation. So like one observation, one for here, there's only so many number of ones. There's only so many 10 minutes. So yeah, so each event is 10 if we just draw it up, but we have puts in this. Yeah. So huge duplication. Yeah, the only rough option here that there's some kind of going on is this technical column. That's basically the support key, which is here. However, basically, Okay, we're going on to the next one, okay? So basically, for here, it's basically we have enrollment for course ID, course quest ID in a section that basically tells you what kind of enrollment somebody's having. And of course, there's a course, and there's many sections to a course. So there's so that's the relationship there, and also for each enrollment, there's many students. So relational algebra, this is basically many operations that relational databases go through. So basically, this is kind of like what the math background for this is. Just understand the basic concepts. Like projections, you're just returning a subset of columns. Selection, you're basically returning only the rows that where some conditions true. We can also rename attributes. We can also join up tables. Natural join basically joins up tables with the same column, same data type. So it merges those two tables together based off those common common table. There's also theta join and equijoin, where you're joining up two tables where some binary condition, we call it theta, is true. So for instance, where attendance we had before, like we could have join up a attendance table and event table with an equijoin, and just basically gives that to we basically have a whole membership information of all the attendance for each event, and also information on that. We also have set operations like unions, differences. This basically operates on the rows, so it basically takes away rows or adds rows together. We can even do a Cartesian product of tuples, where basically for every row of one table, we have all the other rows for another table. So we have a table with n rows, another table with m rows. We have a result would be an m by m table, which is fairly big. So that's hardly ever done. Like, what kind of operation is this, where we're selecting a column? Yep, projection. And what kind of operations performed on this table here? No. First one's projection and
Selection.
right on. And like, what kind of joins can be performed on a table? So how can we join up tables together? Anyone have an idea? Yeah, this one. Natural join, we're basically based off common columns, or theta join, or equal join. So constraints, basically, we could basically limit what's entered into a row using constraints. For instance, primary keys basically uniquely identifies each row. Foreign keys, basically, it points to the primary key of another table, enabling them to easily be joined. Check constraints basically limits the range of values that a field can take. So, for instance, the database here, for paid, and if you have a card, it has a field type where it basically checks that it's either yes or no. And for unique constraints, basically you force uniqueness on a column. For instance, basically if you force that constraint on a column, that exact entry can only be entered once for that table. And not null, basically make sure that the field in a column can take on values that are not null. You can't have like something empty in there. We also could create indexes for like faster searches of tables. It makes it really nice for like when you're doing queries like of huge databases. So that you quickly join up things together, do calculations through SQL. So basically going to SQL language. For SQL, uppercase, lowercase does not matter. Just for here, we're gonna basically have all the keywords like select, from, and where, all those kind of stuff that's built into SQL. Those are we're gonna use it for uppercase, but realistically, you could use lowercase, mixed type, whatever you want, and it'll still work fine. SQL statements are processed as a whole, so it only processes it once it reaches that semicolon line. When it reaches semicolon, otherwise it doesn't do anything. Once it does read that semicolon, it basically does some algebra, relational algebra, and tries to figure out what's kind of the best way of doing this query, and that does up the query. That's kind of one of the neat things about SQL. Is it has an optimization engine that can do that because of that relational algebra engine. So like for our database here, we're going to basically use like this kind of database for Stats Club, where basically a member with a name, email, and if they paid membership dues, and if they don't have a card, unfortunately keep on forgetting to make up cards. They attend events, where the event specifies an event name from here, and where it has a data type, presenter, organizer, all that information like start date, end time, location, budget. Has expenses reference that event. This kind of this one reason why if you have this kind of map, it kind of tells you a lot about what the structure of the organization is and what kind of it does. So this basically, members attend events hosted by Stat Club execs that have positions and jobs and have some budget and related expenses. So for this here, our data on the database is pretty much all fake. So don't have to worry too much about somebody's email getting out there somewhere. in SQLite, there's 5 basic data types: integer, real, where it basically is a sort of like a floating point value. There's also text, that's sort of like a string. Blob is basically just a blob of data. If you put in that place like a picture, it actually stores that picture as the data itself, and so it doesn't really know what it is, just ones and zeros. And numeric basically is sort of like integer or real values, but stored as text. So it's basically exact numbers, but it's a little more. It has to basically read it from and convert it out to real values when it processes it. In SQL, in general, there's various other different data types for each implementation. But there's basically some generalities. Like for instance, there's characters, which basically is string, like fixed length, variable strings. There's also binary strings, Boolean values, true or false. Usually that's implemented as like ones or zeros. There's also very binary integers, small integers, various different types. There's also numeric values. Yeah, like in general, there's for other types of SQL, there's a lot more variety of what data types. So like you even have quite a few have like data types, what basically tells you the date for different things. It's like timestamps and null values. Null values can think of null as an unknown value for this for some entry. So null values basically gives you tells you, okay, we don't know this at this point. Or null values could also be kind of tricky because, for instance, if x or y here is null, then it turns into a null value. If we could do a comparison between where one is a null value, it returns a null value. So if you do a lot of chaining like that, you could possibly end up with a lot of null values and really affect your query. So be careful with that. And yeah, that's why null values are like the necessary evil of SQL. So like it uses basically a 3 value system: true, false, and null. Where basically, if a true and a null value will give you null, or if you do a false and or a null, gives you null. Otherwise, it pretty much works the same as you think. And not null will return null, like not like some unknown value, like some unknown Boolean variable. You don't know if that's true or false, so it's still unknown. So it gives you again unknown. So projection, where we do basically select clause. Here's basically where we're going more into the depth. Returns a set of tables, sometimes specified in the statement. So basically, if you follow along here, like when I do stuff here, you could basically do the follow along and select the example and click here, and does the query there. So first of all, in the select clause, that's where you basically specify your columns, and it gives you also from table. So basically, select the columns we want from this table, and gives you values. If we want to select all the columns, we basically select star. And yeah, if we leave it from, we could still basically makes SQL makes a fake dummy table where it doesn't have anything to do. So if we leave it from table, we're effectively making an empty table, or we could make an empty table, or basically returning some kind of calculation. So in the select clause, we could have basically specify more than just columns, literals, expressions, functions. You also going to have user-defined functions. Postgres SQL is the best one for that. For instance, let's try some literals and calculation of 1/2. So select 1, 2, and that string gives you basically the data back again. But notice there, 1 divided by 2 gives you 0. This is because 1 and 2 are ints, so it always returns an int value in this case, because it's thinking, okay, you supplied 2 ints, so keep within the integers, and the closest value, it basically always does the floor of that value. So let's do this here, where we basically try it various different ways. 4 divided by 2 works fine. 5 divided by 2 still gives us 2. But if we do 1 divided by 2 point, since 2 is a floating point number, it returns a floating point number. So as long as one of them is a floating point, it returns back. And here, 1 divided by cast as 2 as float, that basically casts 2 as a floating point value, and gives us the value right here. This is basically how to transform like one data type of a column into another data type. SQLite statements ignores white space and new lines. So as I said before, it only processes it after the semicolon. So for instance, this query right here gives us and this query right here gives the exact same table back. It completely ignores all the white space, all the white and new lines until it reaches that semicolon. So that semicolon basically tells us, okay, execute this query. If you don't have that in there, it doesn't really do anything. So in SQL, there's various different functions like absolute, which gives the absolute value, length of the string, or what. Lower, we can also lower or uppercase a string column. We can also give random numbers in there. So if you want to, you actually could do Monte Carlo simulation with SQL. It's kind of difficult, but you can do it. And you also could do like linear algebra with some funky ass stuff that. Yeah, so it makes it quite good. Makes it it's a different paradigm, but so like select absolute of -8 and give it find the length of this is a string, and lower of case of that gives us all these values right here. So absolute gives -8 gives 8, length of the string gives 16, and yeah, you can see that how that's going along. And there's also many other core functions in SQLite. So, for instance, here there's a lot of stuff here. You could also do extensions too, like you also could have extensions in for SQLite. So there's like math packages and all that stuff, and so calculate the average of 2 random numbers. Just here's a little quiz part. So just try calculating the average of 2 random numbers and find out, and then find out what's the upper and lower case for the string upper or lower there. Yeah. Yeah, because if we don't say we're from a table, it just basically is, it specifies a dummy empty table. A dummy empty table basically is saying nothing. So it basically just returns these values as calculated. Oh. Yeah, so right now we're basically just doing a really mean calculator.
Yeah.
No, just like specifying not specifying a table, so it's not taking no table.
Can't take something from somewhere if you don't.
Yeah.
You have to grab from somewhere, otherwise it's just like the trash bin. It just gives you nothing.
Yeah. Anyone have any questions? Yep.
For what? Yeah, I care because. Alright, the runs are up. Oh, yeah. Really good. Yeah, I think I think this is up. No. I wouldn't do that to you. Whatever. Yeah, I got like an 88. 81. What's the whatever. Please. What's that? That was the one we did like when we ended last Thursday. Lars and I didn't remember that. How do we get the first one we do together? And how do we not get perfect? I don't know.
Yeah. What?
Why?
This code's called it's like rows. Yeah. Entities as well. Attributes are columns. What? And, well, that's different types of things. Primary key is basically saying this is unique. You can actually have several columns as a primary key. Same thing with foreign keys. Foreign keys basically references the primary key of the table. It's kind of, you can think of it basically as what? Yeah, it's a link in the columns. Like basically saying, okay, I need to reference this in this table. So if you enter something in the foreign key column that's not in the primary key of another table, that's the query would fail. Or won't work. That's actually one of the reasons. Like, that's implemented so that it has consistency. Like, it's always consistent. So if something's not put in right, it just fails it. And it's like, okay, try this out again. Because it needs actually inputted properly. Okay. So I'm going to go on. Everybody pretty good? So if we do select addition of two random numbers, divide by 2, point with a point dot there, would give this here. And upper and lower case, we basically select upper or lower, and then, well, select the upper function and the lower function on that there. And when I typing this up, I forgot to write the semicolon in there. I'll have to write that up, change that later on. Yeah, it gives us this column right here. So makes everything upper, makes all the string uppercase. Lower makes it lowercase. Next, we're going from clause, specifies the table. So either a persistent table, something that's stored in memory, or the result set, or some join. So we basically selecting columns from some kind of table we can construct in there, or table that's already in there. So, like for instance, what are the names, type, and times of and locations for stats clubs, for events? Should actually specify events in there. So if we do this statement here, we give out the various different events and their type, start time, end time, and their location. So from clause quiz. Who are the execs for Stats Club and what are positions and emails? Like, we need a projection of name, position, and email from table exec. So select name, position, email, then from Any questions?
Is it from example or event?
No, from the table exec. Exactly. You could also look up browse data there. Go to exec.
Oh.
So yeah, probably should show. So like if we basically go up here and select event from the browse data, it tells you all the information, including column names. So basically, we just basically want to select name. Name, position, and email from the exec table. So like name, position, and email right here. We just want to select those values. If you need any help, raise your hand. Basically, columns, seven columns. Okay, so everybody good? At least tried. So if we select name, position, email from exec, we get this table right here. So next we're going to go with aggregate functions. So like average, count, or max. These are basically various different aggregate functions. So you could basically use those over columns, and that gives you basically some information. For instance, if we do count 12 of various different data types, we get this back here. So if we do a count of the number 12, there's only one number, so it gives you back 1. Count of a string, there's only one string, so it returns that. Count null, it considers it nothing, so that returns 0. Sum of 23, that's just 23. Sum of 0, same thing, but sum of null, that's nothing, so it returns nothing. Average of 0 gives you 0. Average of null gives you null. If all the entries of sum and average are null values, it just gives a null value back. So let's just basically work some with aggregate functions using an example table right here. This basically is the example table in the database. It's actually named example. So if we do select count star, we're basically counting each row, or if we could do count string, count float, our column floating, or average our number column here, or sum average number value. So we basically there's five unique rows here, so it gives back 5 for the first one. Same thing with strings, with 5 unique strings. But there's only four non-null values in the floating table column here. So it just returns 4. Like that null value in there gives you nothing. And average of the number of that number there gives you that value there. Sum gives you what you expect. And we also have a group concatenate of a string. We're actually also included a space, so it gets all the string column up into to one sentence. Like this is a string instead of what this originally we had each word as a separate thing. Now concatenate everything into one string. Yeah, and remember that's coming. The last line there is from example. Distinct prefix basically is make sure that each row value returned is distinct. We also use distinct values within aggregate functions, making sure that it only aggregates over the various distinct entities inside of it. So, like for instance, what events have Stats Club members attended? Like what are distinct events where at least one member has attended? So that means basically what are the events unique? What are the distinct events inside of the attendance variable table? So if we just select distinct event from attendance, we only give out the list of all the stuff that basically we have records for people attending. Quiz. What are distinct majors of Stat Club members? So remember there's in here, members, the member table. We have fake data of our faculty and major. So we basically want what are distinct majors of Stat Club members. So distinct. If you have any questions, raise your hand. Any questions? Oh, sorry. Data join is basically describing like some kind of join. You can join tables based off of join up tables based on some binary condition. So like for instance, when it's equal, we basically just join up when these two columns are equal. If that is true, then that's when it's added. Understand? Okay, so
How can we know the number for different majors?
what do you mean?
such as there are 4 computer science, 5
So like majors right here. So all the majors are right here.
yes, how can we like
Select distinct major from.
but it can only show how many majors, but I want to know how many people major in like natural science.
For each one?
Yes.
That's with the group statement. That's in the second presentation.
No, I mean such as there are 6 people in actuarial science, 7 people in computer science. I want
Yeah.
to know.
Yeah, to do that up, you have to know the group by statement clause, and that's going to be in the second presentation.
Oh, thank you.
Yeah, right now it's just, very basic.
Okay, thank
Yeah.
you.
So like, so it's column 1, so T1, so that has one column right here from table 1, and so T2 from column 2. So, well, that doesn't matter. So basically, when T1 dot column greater than T2 dot column, that's basically one way of saying specifying the dot. The first one is basically the table dot the column. This basically says, okay, for every row here, that's this condition is true. You join up those tables together, so that row together. So if this is true, like that row and this row, this has this row here, and this row. The result would have this row and this row here joined up together, and so on for every condition. So it evaluates. Okay, is this true for this statement? For this for this row? No. Yes. This is true for this statement? No. For this true for this statement? Yes. For this one? No. Joins up together based on this condition. So this is basically our theta. If they're equal, then basically it just makes whichever, if it's also inner join, and this is m columns, and this is n columns, we basically find that the result would give us the smaller value of m or n, if that was equal. But if that was greater than or less than, we don't really know until it's all done. So equijoin is usually the one that's usually used, but that's why it's all named and everything. But occasionally, other thetas are used as well. Like for second one, for our joins, we describe one that uses something like this.
So this concept being described with the
Yeah, in this second one, it gives more in depth. Like, we're not even tackling joins today. So. Okay. Going on. So, distinct major. We select distinct major from member, and gives us all the distinct majors like stats, pure math, CS, applied math. How many distinct majors of stat club members are there? So basically, we do, instead of, let's just go through this quickly. We select count, distinct, and inside of count, we actually have the distinct and our major, and this just basically returns a number. So basically, it filters out, okay, which ones are unique in this column, and just does a count on them. So we can also give a column an alias. So this basically gives a name to the column. So this helps with readability, and also it helps when you're referencing a column another way later on. So it makes it more readable and workable in general. So if we give column aliases to that whole string before, we had number of strings and count the number rows from example. now we have everything lined up so that we have gives us a return of what this column actually means. So average of integer, average of integers, and so on. So you basically select count as what alias you want to name it as. Same thing here. As is basically gives you what want to rename it as. We also give aliases to tables as well. This is actually really helpful later on, and it's also really helpful when tables have common names. Usually, if you give an alias, give a table an alias, usually a really short one, like I usually do T1 for table 1 if I want to do that, or just basically if for expense I probably do EXP. And we could also reference a column by what the table name is or the alias is, column name, and that actually can tell us what column we were referencing in the query itself. So basically, we form a query using a table alias and for using this kind of structure here. This is also really important for like bigger, complicated ones, like the ones that are like 100 lines long. Kind of want an alias in there somewhere. So just basically, I'd actually specify what I wanted to do with this. Okay, go on. So as I say, select e.name, where I had before, so for event, I renamed the column as E, renamed our table as E. So we have select e.name, e.start time, and description, location. Do you guys want to continue on, or should I basically put the where clause into the second SQL? Do you want me to keep on going, or do you want me and put this the where clause into the second presentation, or do you want me to continue on and finish this up and continue on? Put in the second one. Okay, so put where into the second one?
Next one.
In the March 12th?
All hands for right now. All hands for next one. Okay, there's more for next one. So
Okay. 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 So next one we're gonna have basically a where clause as well, but on March 12th. And this is basically what we're going to do. The where clause, also aggregation, joining tables, subqueries, set operations, with clauses, whole bunch of stuff. Hopefully be able to get through everything then.